This is question 2 from the Chapter 4 review. This is the FRQ section, and we are working on section B of this problem. So section B of this problem is saying, using correct units, interpret the meaning of the integral from 0 to 60 of the absolute value of the velocity, dt, in the context of this problem. So we have to interpret the meaning before it asks us to solve it or find any number associated with it. And I mentioned this in the first during the first problem, that if they want you to interpret the meaning of a type of question before finding an exact answer, you can be a little bit less specific than you would have to be if you actually found the answer and then had to interpret what it meant. So we can say rate of change rather than rate of increase or decrease because we don't know yet whether it's an increase or decrease, that kind of thing. So in this case, we have to interpret the meaning of this particular formula, which is why it's a very good idea to make yourself flashcards or to study in particular these 3 types of equations that we've already went over. We have an average value equation, we have a displacement equation, and we have a total distance traveled equation. And if you notice, this equation here has an absolute value, so it must be one of these 2. And the absolute value is inside the integral. It's inside just around v of t, so it's not this one. It is total distance traveled. Or in this case, total meters per second. So yeah, we're looking at total distance traveled here, okay? So that means that in this case, what we're looking at is when we integrate velocity, we're going to end up back at position. So if we were integrating acceleration in a problem like this, we would be talking about total meters per second, so total speed, that kind of thing. But because we are starting at velocity and integrating, we will end up back at meters. So we are actually calculating total distance. The units that we're going to get out of this are a measurement of distance because we're going from velocity backward to a position function, okay? So if we want to interpret the meaning of this integral, this will be the total distance. This part is given to us by the shape of this function. But there are a couple more things that we need to mention. We can't just say this is the total distance traveled. We have to say this is the total distance traveled and put it back in context of the problem. So who is traveling? Ben. He's unicycling, we can mention that. You don't have to phrase it just like this. You can say this is the total distance that Ben is unicycling. This is the total distance biked by Ben. I don't know how you want to phrase it, as long as you mention that it is Ben doing this action because he is the star of the story, if you will. So the total distance traveled by Ben on his unicycle, and we're almost done, okay? So the fact that we talked about total distance and Ben, that's awesome. We also have to talk about the time frame, okay, and the units. So total distance traveled by Ben on his unicycle, what units are we using? We're using a measurement of distance, which is meters. So we can say in meters, and you don't have to put it in parentheses, I just like phrasing it that way. So the total distance traveled by Ben on his unicycle in meters, so now we have our units. And we have one more thing to mention that you always, always, always must mention when you are explaining these types of functions, and that is time. So in the first problem, part A, we were just talking about at 12 minutes. In part B, we were talking about between 0 and something minutes. So it's either at or between values. In this case, we're integrating from 0 to 60. So we have to say from 0 to 60 seconds, okay? So we can say between or from, it doesn't matter. So between 0 and 60 seconds, okay? So however you want to phrase it, it's up to you, but you have to mention time, units, the story, and what the function means. So you're always going to say this is the total distance, or this is the rate of change, or this is the position, or this is the average value, or something like that about what the function means, and then something about the story, this is Ben on his unicycle, and then something about time, this is in between 0 and 60 seconds, and then, of course, you want to mention your units in meters per second, in meters per second squared, whatever it happens to be. You have to mention all of those things, okay? Now, that was part one of question B. We also have to approximate this answer using a left-hand Riemann sum with the subintervals indicated in the data. So what we're doing here is we are approximating the sum of the distance traveled, right? So what we're going to do for that is we're going to have to make intervals up here, the subintervals that they've indicated. So we have 1, 2, 3 that they've given to us, so those are the only 3 we have to worry about using. We know we have to use a left Riemann sum, so we're going to use the left side of the table here. So it's going to be one of these values here. We just have to figure out which one. So time is always going to be your x value, no matter what. So time is my x value, which means my x value is my horizontal part, and if I'm making rectangles on top of my horizontal part, the x values are going to be the width. So we can go ahead and fill those in. So I have 1, 2, 3. 3 different rectangles. And because I'm doing this problem with the absolute value, the total distance traveled, I need absolute value signs in here. I don't want them to take off. I don't want any negative values in here. These all have to be positive, okay? So absolute value, absolute value, absolute value. So we said that the time is always my x value. So remember, it's not just picking the left side. You do that with the height, not with the base. The base you actually have to calculate. So from 0 to 10, my first base is 10. From 10 to 40, my second base is 30. And from 40 to 60, my third base is 20. So I have all my bases. Now to find the height, what's important here is they've asked us to find the integral of v of t using these sums. So v of t is where we're going to find the height of each one of our rectangles. V of t is on the bottom. Don't be misled and think that it comes from meters because our final answer will be in meters. We are finding the area of the volume and that will give us the total meters. So we will go ahead and use these numbers in the bottom row, and we will use the left-hand value for our first height. So this is 2.0 in our first rectangle. Second rectangle, the height is 2.3, and our third rectangle, we'll use the left-hand side, it's 2.5. This is a right-hand value. We won't end up using it in a left-hand sum, okay? At this point, I have my absolute values, I have my base and height for each rectangle. I'm finished. I do not have to simplify. This is an FRQ. I stop here, okay? And we've already explained what this means. It doesn't matter if this is anything specific, positive, negative, that kind of thing, because my explanation came first. So this is all I have to do for my Riemann sum, okay? And I'm finished. So we'll do part C in a separate video.